Dear children, welcome to the YouTube channel H2O Chemistry. I am Satya Narayanan, your chemistry teacher. Subscribe for more videos. You will find chemistry easy here. In this video, we are going to talk about the concept mole. If you come directly to this video, kindly watch gram atomic mass, gram molecular mass, then Avogadro number, finally watch gram molecular volume. So after that you will find this concept so easy. What is the meaning of mole? The meaning of mole is collection. So we are not talking about a single particle here, we are talking about a collection of particles. So the mole concept is used especially for microscopic particles. What are microscopic particles? The particles such as atoms, molecules, ions, electrons, protons, neutrons, etc., which normally we cannot see through our naked eye. Got it? So the mole concept may not be applicable for the macroscopic particles such as books, pens, pencil, laptop, books, TV, television, so whatever we see through our eyes. So the mole concept is specifies something. It talk about the size of the very small size of particles, but it talk about the number of particles. That means collection of particles. The number of particles is so huge. So the mole talk about, or mole concept is used for very small size of particles, but the number of particle in mole is so huge. So let us understand more about it. Why do we need this mole concept? Practically, it is not possible to know the weight of single atom. So after separating a single atom from any element, if you go and weigh in a physical balance, nothing you will see, because the mass of atom is so small. So in order to avoid that, we use this method called mole. So you might have studied in SI unit, the amount of substance is measured in moles. And I can say in other words, it's called counting unit. This system is not new to us, because we do have a whole system like this. A dozen, if I say, you will say 12 items. If I say pair, you will say 2 items in it. Or if I say pawan or sovereign, you'll say 8 grams of gold it is. Likewise, so 12 items if I have, you will say dozen I have. Similarly, you understand the concept called mole. 1 mole contains 6.023 in 10 to the power of 23 particles. This is very huge. This is very huge. Got it? Which is applicable to microscopic particles. But the size of particle is so small, but the number of particle is very huge. Indicated by a symbol called Na, Avogadro number of particles. Avogadro number of particles. So what is the definition we can give? A mole is nothing but this: any substance that contains 6.023 in 10 to the power of 23 particles, or Avogadro number of particles, is called 1 mole. It's called 1 mole. So let us find out a little bit more about this moles. I have around 12 pencils, so we will segregate so that you will understand more about this. So I have around 12 pens all are same in color and same in size. Let's think of all our atoms. So this atom weight is so small I cannot weigh it, right? But as a whole, if I collect together, if I hold it, I can feel some mass, right? So that is the idea behind the moles. But the particle size is so small, but as a collective. Now, how do you calculate the weight of one pen here? So I have a 12 pens here, right? One pen weight is very less, but what I can do, I can do like this. I can take 12 pencils, 12 pens like this, and then totally I can weigh that. If I divide the weight by 12, I get the weight of this one pen, right? That's a concept used in mole, right? Now, so you know the definition of mole now, and why it is used also you know now. Now, you'll see the next one, that is, what are all the substance contains 6.0 to 10 to the power 23 particles? Let's come to the topic. The gram atomic mass of an element and gram molecular mass of an molecule contains 6.023 entities. The word entity, it may be replaced by atoms or molecules or ions or electrons, protons, neutrons, etc. So that point you should be very aware of. Wherever the entity comes, it indicates these, any one of these. Now, what is the conclusion we can make? If mole contains 6.023 particles, even a gram atomic mass GAM or gram molecular mass GMM also contains 6.023. Can I say these gram atomic mass or gram molecular mass is equal to 1 mole? Yes, that is an answer. Let us see. Look at here. Therefore, I can conclude the gram atomic mass of element or gram molecular mass of molecule is equal to 1 mole. Reason is 1 mole contains this Avogadro number of particles. Even a gram atomic mass of an element contains the same. For example, gram atomic mass of carbon is 12 grams, which contains 6.0 to 10 to the power 23 atoms of carbon. So I can guarantee say 12 grams of carbon or gram atomic mass of carbon is equal to 1 mole. Is equal to what? 1 mole. So from this, what we can conclude? The gram atomic mass of carbon is 12 grams, which is equal to how many mole? 1 mole. So what is the mass of 1 mole of carbon? 1 mole of carbon is 12 gram, because GAM is equal to 1 mole. What is GAM of carbon? Carbon is equal to 12 gram. So which is equal to 1 mole. So the mass of 1 mole is equal to 12 gram. I can say mass of 1 mole of carbon is equal to 12 gram. Mass of 1 mole I can otherwise called as molar mass. So the molar mass of carbon is 12 grams. It's a very important area. Molar mass is mass of 1 mole. Mass of 1 mole, which is nothing but gram atomic mass of the particular element. Come to the next category. Gram molecular mass of any molecule is equal to 1 mole. Even a gram molecular mass of a molecule contains 6.023 in 10 to the power of 23 molecules. 23 molecules, right? So let us have an example. Gram molecular mass of oxygen is 32 grams, which contains 6.023 in 10 to the power of 23 molecules of oxygens. You need to specify this molecules or atoms. Remember, so 6.023 in 10 to the power of 23 molecules of oxygen, it contains 32 grams. So from this, what we can conclude? So 32 grams of oxygen molecule or gram molecular mass of oxygen is equal to how many mole? 1 mole. So the gram molecular mass of oxygen is equal to 1 mole means, what is the mass of 1 mole? Mass of 1 mole of oxygen is equal to 32 grams. You can otherwise say molar mass of oxygen is 32 grams. Because mass of 1 mole we can replace by molar mass. We can replace by molar mass of oxygen molecule. This is 32 grams. So what is the conclusion we can make out of this? So look at this area. Gram atomic mass or gram molecular mass is equal to 1 mole. So the very similar thing we can conclude. the gram atomic mass or gram molecular mass equals to 1 mole. These all contains 6.023 in 10 to the power 23 particles or entities. Right. We have learned one more concept in the last video, that is a gram molecular volume, otherwise called molar volume. So I told you I will explain the term molar volume in this mole concept. So let us see. The gram molecular mass or 1 gram volume of oxygen, which is a gas, oxygen O2, oxygen molecule, is equal to 32 grams. So gram molecular volume is nothing but 22.4 liters. So this volume, this gram, if you weigh 32 grams and keep it in a particular any vessel, closed vessel, the volume occupied by the gas, oxygen gas, will be 22.4 liters, 22.4 liters at STP, at STP. So it is a gas, remember. So I can confirm the gram molecular mass equal to 1 mole, which contains how many number of particles? This many number of particles, that means Avogadro number of particle. The same occupies how much of volume if it is a gas? If it is a gas which occupies 22.4 liters at STP. So further I can conclude this area is very important. The gram atomic mass of an element or gram molecular mass of molecule equals 1 mole because it contains 6.023 in 10 to the power 23 entities, and if it is a gas which occupies 22.4 liters at STP, remember this. So gram molar volume is equal to 1 mole. That's why it is called molar volume. It is called molar volume. The value is 22.4 liters at STP. 22.4 liters at STP. Hope it's a very simple idea, my dear children. Let us have a small revision on that with the help of this concept. Let us assume that the mole concept explained easily. I have 4 vessels in it. The volume of the vessel is constant, and in the first vessel I have taken 12 grams of carbon, which is nothing but gram atomic mass of carbon. The next vessel I have taken 32 grams of oxygen molecule, which is nothing but gram molecular mass of oxygen. In the third vessel I have taken 28 grams of nitrogen with nothing but gram molecular mass of nitrogen. The last vessel contains a 17 grams of ammonia, which is again gram molecular mass of ammonia. All the 4 vessels nothing but gram atomic mass or gram molecular mass, so all contains Avogadro number of particles. Avogadro number of particles, right? Now one thing, carbon is solid, so the next concept is not applicable to this, but oxygen, nitrogen and ammonia are gases. So the gram molecular mass contains Avogadro number of particles, which is a gas, so occupies 22.4 liters at STP. Similarly, this nitrogen contains Avogadro number of particles, which also occupies 22.4 liters at STP. Similarly, ammonia, which occupies 22.4 liters at STP, which also contains 6.023 in 10 to the power 23 molecules of ammonia. So all are equal to 1 mole because it contains this many number of particles. The weight of this is this and occupies this volume, right? And with this I will explain the Avogadro hypothesis also. Equal volume of, look at this, equal volume of all gases, O2, N2, NS3, all gases under standard temperature and pressure, standard condition of temperature and pressure, contain same number of molecules. See, I repeat, equal volume of all gases. This is also 20.4 liters, this is also 20.4 liters, this is also 20.4 liters, right? Equal volume of all gases under standard temperature and pressure contains equal number of molecules. This is called a hypothesis of Avogadro. Very simple idea it is, my dear children. From whole concept you can easily teach this. Thank you so much for watching. I hope it helps in learning. Thank you.